Hello, teacher. My name is Nguyễn Anh Khôi, and my teammate is Nguyễn Thành Đạt. And today we will represent to you a business model that we have thought of our own for this schema. We designed the system to support the operations of a real estate company. And this system is designed to support the daily operations of a real estate brokerage company. It will help manage information about property owners, properties, agents, clients, contracts, and payment installments while maintaining the relationship between these entities. First, we will talk about the owner entity. An owner represents the legal owner of one or more properties, and each owner has a unique owner ID along with their full name, phone number, and email address. According to our business rules, one owner can own zero or one or many properties. However, every property must belong to exactly one owner, so the ownership of each property is always clearly defined. Next is the property entity. Each property has a unique property ID as well as information such as its type, price, and current status. One important feature is that the property's address is modeled as a composite attribute. That means instead of storing the address as a single field, we divide it into house number, street word, district, and city. This makes searching and filtering properties way more easier. A property may or may not be assigned to an agent. Also, a property can appear in multiple contracts over time. For example, an apartment can be rented to different tenants across several years. Our next entity is agent. Each agent is identified by an agent ID, and we store their full name and professional license number. Agents will have two main responsibilities. First, they manage properties. One agent can manage many properties while each property is managed by at most one agent only. Secondly, agents execute contracts. Every single contract must be handled by exactly one agent, but an agent may execute many contracts throughout their career. Each agent has a unique client ID, a full name, a client type, and which can be either a buyer or a renter. A client can sign zero or many contracts. For example, one customer may buy multiple properties or rent different apartments over time or even at the same time. However, every contract is always associated with exactly one client. The contract entity is the core of the system because it connects the major entities together. Each contract records the sign date, contract amount, and contract type. Every contract is linked to exactly one property, one client, and one agent. Although each contract only references one property, the same property may appear in multiple contracts over time. This will allow the system to keep historical transaction records. And finally, we have the payment entity. Payment is modeled as a weak entity because it cannot exist independently. Every payment installment belongs to exactly one contract. A contract may have zero, one, or many payment installments depending on the payment agreement. Each payment stores its payment amount and payment date. This payment ID is only a partial key, meaning it is unique only within the corresponding contract. Therefore, the payment is uniquely identified by the combination of the contract ID and the payment ID. And next up, my teammate will represent the next part, which is the ER diagram.
Okay, now I would like to represent our entity relationship diagram, or we can know as the ER diagram. So let's begin with our entity. Each owner is identified by owner ID, which is a primary key. The system also stores our full name, phone number, and email. The relationship between owner and property is called out. The cardinality is one to many. This means that one owner can own multiple properties, but each property is belong to exactly one owner. This ensures that every property is always has a clearly defined legal owner. Next is the property entity. Property is identified by property IDs. Each attribute includes property type, price, and status. One important feature is full address, which is modeled as a composite key, a composite attribute. Instead of storing the address as a single value, we divide it into house number, street, ward, district, and city. These designs improve the flexibility because users can search properties by distinct cities and streets individually. Properties have also had a relationship with agents, which call manage. This relationship has a cardinality of 0 or 1 agents for each property and 0 or many properties for each agent. This means that property may not yet have assigned agents, but once assigned, only one agent is responsible for managing it. Meanwhile, an agent can manage many different properties. Now let's look at the agent entities. Each agent has an agent's ID as a primary key together with the full name and the license. Besides managing properties, agents can also participate in execute contracts. Each contract is executed by exactly one agent, while one agent may execute many contracts through their career. This allows the company to monitor each agent's sales performance. Next is the client's entity. Each client has their own client ID along with their full name and their client type, which indicates whether the client is a buyer or renter. The relationship between client and contracts is called size. One client may sign many contracts over time, but every contract belongs to exactly one client. This reflects real-world situations where a customer may purchase or rent multiple properties in different transactions. Now we will come to the contract entity, which is a central entity in our ER diagram. Contracts contain attributes like contract ID, sign date, amount, and contract type. It connects three important entities together: property, clients, and agents. The relationship between property and contracts is called trade via. A property may participate in many contracts over time. For example, an apartment may be rented repeatedly to different tenants. However, each individual contract only refers to one specific property. And finally, that we have a payment quick entity. Payment represent asset quick entities, which is shown by a double rectangle in ER diagram. The defined relationship has installments. It also shows using a double diamond. The payments cannot exist independently because every payment installment must belong to the contract. Each payment stores the payment amount and payment date. Notice that payment ID is represented as a partial key, which meaning is unique only within a particular contract. Therefore, the complete identifications of payment require both contract IDs and payment ID. This accurately models installment payments in real business situations. And so it is then of our represent for the or diagram.
So this is the relational schema converted from the ER diagram of the real estate brokerage system. The schema consists of 6 tables: owner, property, agent, client, contract, and payment. Firstly, there are 3 core entity tables, which is owner, agent, and client. This is the independent entities, each with its own primary key and descriptive attributes. For example, the owner we store the full name, the phone number, and the email of the property owner. And if these doesn't have any foreign key because they are independent and they does not depend on the entity. Next table, the center of the schema. The property table sits at the center, and address was originally a composite attribute of the ER diagram that was made up of house number, street, word, etc. So when we convert it to a relational model, we flatten it into separate columns. We have 2 foreign key, which is the owner ID and the agent ID. And mandatory because it will connect to the other table to get the necessary data. And the property table will have 1 primary key, which is the property ID. Next is the contract, which is the 3-way link. The contract represents the relationship that ties together the property, client, and agent. Each contract is linked to exactly 1 property, 1 agent, and 1 client. All 3 of those foreign keys are mandatory because a contract can only exist if all of which are determined and none of them can be null. And lastly is payment, which is the weak entity. Because payment installment has no independent meaning outside the contract it belongs to, which means if there are no contract, there are no need for a payment entity. So payment's primary key is a composite key that contains of 2 attribute, which is contract ID and payment ID, where payment ID is only a partial key, unique within the scope of a single contract, but it is not unique across the entire database. Uh, and overall, this design it will avoid data redundancy and make sure that there are no not null and null data in appropriate places.